Alright, 1-1, patterns and expressions. Here's your vocab. Constant, quantities whose values do not change. Variable quantity, quantities whose values change or vary. Variable, a symbol, usually a letter, that represents one or more numbers. Numerical expression, a mathematical phrase that contains only numbers and operation symbols, such as 3 plus 5, or 8 minus 2 plus 5. The operation symbols are plus, minus, multiply, and divide. All right, algebraic expression, a mathematical phrase that contains one or more variables, such as 3n plus 5 or 8x minus 2 plus 5n. Easy way to tell which one you have, if you have a number in your, if you have a variable in your expression, it's algebraic. If you only have numbers, it's numeric. All right, so pause the video, make sure you get those written down. All right, problem 1, identifying a pattern. All right, so let's look at these 4 figures. What we want to do is we want to find some kind of pattern between them. So what is changing between them? Well, here we have a triangle. How many sides does a triangle have because they're all the same color? Well, a triangle has 3 sides. Here's a square. How many sides does it have? Well, it has 4. This is a pentagon, it has 5, and then hexagon has 6. So what it looks like is we're increasing by 1 side each time. So if we went from here to the next figure, we added 1, that means we would have 7 sides. And that's what this says. The pattern shows regular polygons with the number of sides increasing by 1. So since our last figure has 6 sides, our next figure would have 7 sides, or a heptagon. Name's not as important as knowing how to find the next symbol in the pattern. All right? So, basically you look and you see what's changing and you try to figure it out from there. So now, see if you can figure this one out here. Look at the figures from left to right. What is the pattern? Draw the next figure. So pause the video. All right. If you notice, we have a black square, a black center square in each one. So there we have a black center square. Then in our first figure, this is our first, second, and third figures. First figure, we have 1 square on each side. Here we have 2 squares on each side. Here we have 3 squares on each side. So our fourth figure would have 4 squares on each side. I know this is kind of terrible, but you get the point. All right, so hopefully that's what you got, all right? Because the only thing that's changing is we're adding 1 more square to each side as we go up, all right? Now, we can also use a table to help us figure this out with our figure number or our input, a process column, which we use to help figure out the process, and then our output column. So here we have some toothpicks and that make up some squares. This is our first figure, second figure, and third figure. So let's put those over here, figure number 1, 2, and 3. It doesn't matter what the figures are. This is your first one, this is your second one, and this is your third one. All right, so now our process column. How many toothpicks are here? Well, we have 1, 2, 3, 4. So it looks like our first figure, we have 4 toothpicks. 1 times 4 is 4. All right, 4 toothpicks. How many toothpicks do we have here? 1, 2, 3, 4. 1, 2, 3, 4. There's 4 there. 4 there. We have 2 4s, and this is our second figure, so 2 times 4, which is 8. And then repeat the process over here. We have 3 4s, and it's our third figure, so 3 times 4, which is 12. So it wants to know how many are in our 20th figure, okay? Well, if you look, we're just taking this number, putting it there, and then writing times 4, basically after it. So this is just going to be 20 times 4, which is 80. And there we figured out how many toothpicks are in the 20th figure. All right, now let's take that one step further and says, what is an expression that describes the number of toothpicks in the nth figure? All right, well, if we added another column down here and did n, all we're going to do is take that n, write it here, multiply it by 4, and get 4n as our expression that describes this pattern. Okay, so 4 times n describes this pattern. Because if we added a fourth one, all right, say we had a fourth figure that looked like this, you'd have 4 more toothpicks. Well, 4 times 4 is 16, and that'd be 16 total. All right? Now, let's look at a pattern with numbers. So here we have a numerical pattern. We have 6, 12, 18, 24. So we need to figure out what's going on from here to here. All right, we can make that table if you want to. Input, process column, and output. So we have our first, second. This is 1, 2, 3, 4, 2, 3, 4. All right, so here we have a 6. So we know we're going to use the 6. Well, using our input, what in 6 is 6? Well, it looks like 1 times 6 gives us 6. All right? And if you notice the difference here, this is 6 times 1. Well, what's 12? Well, that's 6 times 2. And 18, well, that's 6 times 3. So what it looks like is this would be 2 times 6, 3 times 6, and 4 times 6 to get 12, 18, and 24. So now let's go ahead and get the next 3 numbers in our pattern. Well, following our process column, following the pattern we found, this would be 5 times 6, which is 30. This would be 6 times 6, which is 36. And this would be 7 times 6, which is 42. All right? Now, again, if I asked you for the nth number in this term, all right, since all we're doing is just doing our figure number times 6 all the way down, our figure number is now n, and we're going to multiply that by 6, and of course the more acceptable way to write that is 6n. All right? Now I want you to try this one. Pause the video, see if you can figure this one out. All right, if you want, we can do the input, the process column, and the output column. If you want. You don't have to. Here, if you notice, 3 to 6, 6 to 10, and 10 to 15. Well, what's going on? Well, 3 times 2 is 6, but 6 times 2 is not 10. Well, 3 plus 3 is 6, but 6 plus 3 is not 10. But 6 plus 4 is 10, and then the difference between here is 5. So here we're adding 3, this is plus 4, and this is plus 5. So there we found out our pattern, so now we can write the next 3 terms. So once you figure out your pattern, you can go ahead and finish out your terms. This will be plus 6, which is 21. This will be plus 7, which is 28. And this will be plus 8, which is 36. So as you can see, patterns come in all shapes and sizes. And this one here, if you were to do it, you would notice that you're multiplying by 3 each time. Times 3, times 3, times 3, times 3. So again, to get the next 3 terms, you would just simply multiply by 3. All right, and that's it. See you tomorrow in class.